Imagine if you could look inside the body and be able to see what's going on. It's an incredibly powerful technique. And many years ago, I realized that we have to be able to develop that to really understand how cells interact with each other, what they're doing, and how they're fighting, for example, infections. And so we started off with some very simple microscopies, just white light microscopies, just being able to look at different cell types. Realized that without taking it up a notch, we never really understood what kind of cells we were looking at. And so then we moved to systems like two-photon microscopy, spinning disk microscopy. These are microscopes that now allow you to inject a tag and light up all the neutrophils red, light up all the platelets green, light up all the macrophage yellow. And we can now look at how these cells interact. You put in a pathogen and you can visualize which cells get there first, what they do to the bug, what other cells come in, are there any problems, and how could we fix those problems. So from a discovery basis, we now understand the mechanisms, and now we can start testing drugs to see if they actually work. And so that's the power of imaging. Yeah. So let me give you an analogy. If you send somebody out to hunt ducks with a semi-automatic gun, someone else might get hurt besides the duck. And that's basically what the neutrophil has. It has this incredibly powerful machinery to help destroy pathogens. Unfortunately, there are bystander cells that every so often get hurt. And what we have found is that when the neutrophil releases its contents in a desperate attempt to kill bacteria in the bloodstream, the contents are all kinds of nasty proteases, the contents are histones and other pore-forming molecules that cause cell lysis and cell death. And so what we've learned by studying these nets and visualizing how they're formed is that they'll attach to the vasculature and they'll cause tremendous injury in the vasculature. Numerous groups have shown this leads to thrombosis, poor perfusion, then the tissue injury that happens. And so even though the nets are very important in fighting infections, they also contribute to injury and tissue injury. And so if we could find ways of maybe modifying how many of these nets are made or for how long they're made, we might be able to reduce the injury that occurs. I think the platelet as an immune cell has been completely ignored. And I think that the platelet functions to help the rest of the immune system get rid of different pathogens. And I think that as we move forward, we need to understand what pathways are important for helping us eradicate pathogens versus what pathways are important to target for example, cardiovascular disease. If we could somehow find drugs that separate those two pathways, we could be maybe much more effective at therapeutically intervening in cardiovascular disease without in any way impairing a patient against infections. And so I think the future looks really bright because we now understand these different mechanisms. Now we just have to find the right drugs to be able to help patients. And so I think that from that perspective, that's where the future lies. That's where we need to go. And that's where we're trying to go, to understand these processes.